Great, thanks very much. Although I speak as PI of UK Biobank, I've always, since its inception, thought that a biobank was exactly the wrong word for UK Biobank. Because I think in most people's minds, the idea of a biobank is a collection of samples in people who have disease. At least that's what it was. Whereas I think, and it's caused a lot of confusion. So I always try to emphasize the difference between a large prospective cohort where you're getting people largely without disease and following them long term from what I consider to be biobanks, which are collections of samples in people with disease. So I'm going to focus on prospective cohorts, and the advantages of prospective cohorts are obvious. From an epidemiological perspective, you can look at not only the genetic determinants, which largely aren't influenced by the development of disease, as well as all of the environmental, lifestyle, and other important determinants of disease. And that can help to avoid reverse causality, particularly if you have long enough follow-up that you can exclude the first few years after recruitment, where you may already have some underlying disease. And of course, it's much more of a like-for-like comparison in terms of comparing the people who over a long period of time do develop disease with those who don't, in terms of your controls. I think also it's a very holistic approach in that you can, particularly if you're thinking of building a resource, which was what the intention was with UK Biobank, you can study the effects of a single risk factor on many different diseases, or vice versa, the effect of many risk factors, genetic, environmental, lifestyle, etc., on a single condition, and of course, the combination of those things. So in the long run, it's a very, very effective strategy. But my first action on being asked to take on UK Biobank was to cancel the interviews for a head of communications, because the last thing I wanted to do during the first 10 to 15 years of UK Biobank was to communicate anything. And one of the biggest problems the study had, and we've seen it with all of us as well, is it was being attacked for not having done anything in the first few years. And really there was a lack of understanding that these studies take 15 or 20 years of investment, both academic and financial investment, before they start to pay off. And in fact, when I was asked by the funder review panel a couple of years ago about UK Biobank, when they were looking at the 5-year renewal, what had UK Biobank achieved that it was set up to achieve, my answer was nothing. There was a moment of silence, but it was the true answer. It's only when you get to this point, 10 or 15 years later, that you can start to get returns. So they have to be very large, and I think we're now, everybody now is accepting that, both the genetic and the epidemiological environment and community, but they also have to be very, very long term. Again, just to emphasize the point that Mark was making about the value of establishing them in different settings, I think the reason for setting up prospective cohorts in different populations should be a scientific one, not a political one. You've got a biobank, therefore I'm going to have a biobank, is not a strategy. At least it's not a scientific strategy. But that is actually what's happening. We're seeing governments around the world saying, well, we better have one too. Whereas if we think about them instead as resources, like CERN, and we think about they are available to everybody, then the question is, how do we set them up around the world in those places that will be a scientifically complementary strategy in, again, the way that Mark said, in terms of getting populations with different levels of exposures, with different genetic structure, with different rates of diseases, esophageal cancer, rare here, common in China, stroke, hemorrhagic stroke, particularly rare in the West, common in Asian countries. So how do we have a complementary scientific strategy and stop funders, politicians, just setting them up because they have to have one? It's not a car. We need a scientific strategy. And I think that also we need to think that, as again was pointed out, that if you have many different studies, then you can meta-analyze, you can test in different populations. If we develop a genetic score in one, can we check how valid it will be in different populations? An important confusion is this idea of representativeness. Again, we're not trying, when we set up a cohort, to work out who will be elected as the next prime minister next week in the UK, or who will be president or whatever. What we're trying to do is get heterogeneity, not representativeness. And it's an important distinction, because this idea that we should ensure that we have a population in the study that represents the population in which we're going to, we're doing it, is not actually valid. The Framingham study has been very useful, but it was only done in one small town in the US, but it has been generalizable, as with the British doctors study done in doctors, finding that smoking was important. Not only was it important for doctors, it was important for others. So it's getting heterogeneity within a population and across different populations. So I think the thing that we're kind of thinking about, and we've had the opportunity with UK Biobank because of the kind of long-term commitment of the funders, is how do we make cohorts better? And like everything you do, when you do it, you learn how you would do it better next time round. So what would be better about UK Biobank? Well, it would have been better if we had had more time and got more information about every participant, more detailed characterization of the participants at baseline than we were able to do. And I say that because there are attempts, I think, to set up cohorts where you allow people to answer the questionnaires they want to answer, or do the physical measurements that they want to do. And the danger is that when at the end of 20 years you say, well, how many people have got these questions and these measurements? If one quarter have done the questions and one quarter have done the measurements, then obviously the proportion that have done both is going to be very small. So you really want to have as much as possible in everybody in terms of questions and measurements. Again, in terms of where should we put these cohorts, the most important thing in a cohort is not the beginning but the end. How do you find out what's happening in terms of health outcomes? So when Zhengming Chen set up the Rory Biobank, he set it up in places in China where you would be able to follow people up. And so the important thing was, how could you follow it up? But when doing that, you can think about, well, also, how could I follow them up backwards as well as forwards? How can I find out as much about them before they join the study, from their health record systems, from other systems, about education, about their social background, that would enhance your characterization of the participants, about previous exposures? Again, thinking about UK Biobank, what would have been better? We did 100,000 people where we got of the 500,000, where we got them to wear accelerometers. So that's great for the 100,000, but it would be much better if everybody had left with an activity monitor on. And indeed, it would be better if we put more monitors on them. What else could we now do in terms of monitoring them? Cardiac rhythm monitoring. You think about atrial fibrillation as it comes and goes. If all you do is an ECG, you'll only pick it up when it has come. You won't pick it up when it's coming and going, and you really need to be wearing these devices for weeks, if not months, to pick up all of the arrhythmias. But what about variability of blood pressure? What about people's mobility? Would that be a good way of determining over time cognitive decline, neurodegenerative conditions? So not about just characterization, participants' baseline, but enhancing your information about their outcomes. We always said in UK Biobank that we would, every few years, get random samples of the participants in order to be able to at least assess variation over time. Why only a small proportion? Well, that's all you really need to be able to take account of so-called regression dilution, to not underestimate the impact of the baseline measure. But ideally, if you really wanted to look at what is the impact of change on outcomes later, you would like to repeat the assessment in everybody, every few years, or every 5, every 10 years, in order that you could look at the impact of change on subsequent outcomes. The other thing we've been thinking about, well, what other ways might one enhance that? Would you just get repeated assessment in individuals? Well, what about recruiting the children of participants to get these multi-generational cohorts? So rather than more people in a cohort, more structure within the cohort that you have. And in terms of biological samples, the thing that became very clear to us, that although in UK Biobank we had the resources to collect quite a lot of sample, we collected 55 mils of blood into lots of different tubes, we collected spot urine, and in the latter part of recruitment we also collected saliva, it's not going to be enough. The more blood you can collect, the better. The more different types of sample you collect, blood, urine, stool, what else? What else should we at the beginning there was thought about, should we be getting nails, should we be getting hair? What other things would it be useful in terms of sample types? And to think about or imagine how they might be analyzed in the future. How do I put kind of preservatives, but how do you collect them in ways that would allow you to analyze many different kinds of things that maybe haven't even been invented now? And again, UK Biobank, Tim Peakman and Paul Elliott did a lot of piloting of this with support from scientists around the UK to try to ensure that one could do this. But the more you can collect at that point, the better. And again, if you had repeat assessments, the more you repeated that, the better. But as I say, I think the key thing is one needs to do it across the whole of the cohort in terms of collecting those samples and then doing nothing with them. My second action with UK Biobank was to send back the analyzers that had been ordered, because I said, first of all, we don't have the money to do that. It'd be better to focus on the participants. And secondly, I don't want to analyze the samples now because I don't know what I want to analyze. It's much better to collect the samples and then wait. Because again, when you think of the samples, they're your gold. And you really have to be thinking about how to get the most information to make the resource as valuable as possible. So uncontrolled assays, let's do the samples in the cases of heart disease and the controls. It's great for a quick win, but it depletes sample. And if you're going to do the same assays in the people with, say, diabetes cases and controls, or stroke cases and controls, then you've got all these nice quick wins, but the assays will be different. And you won't then be able to compare them as easily because there will have been shifts between the different nested case control collections. So by contrast, cohort-wide assays are actually much more cost-effective. We got a really great deal when, with the funder's support, we were able to say, we've got £20 million, we need to genotype all 500,000, who will do that for us? And remarkably, both companies came back with exactly the same price of 20 million for 500,000 people, which was quite a lot less than they had been originally asking. So, you can get very good deals, minimizes depletion, improves quality control. So when we pull the samples out, we pull them out in a random order, so that you use the cohort as your quality control. There should not be shifts over time because you pulled them out in a random order. You've not been doing the men first and then the women, or the people from the north of England who have somewhat higher cholesterols, and the ones from the south. It supports, unlike the nested case control approach, lots of different comparisons, and it yields data that are shareable. Sample is not shareable, data are shareable. So in the short term, it may be much more cost effective to do case control studies. And you get quick wins and you get papers, et cetera, et cetera. But what you do is you destroy the resource. As a resource, in the long run, as it becomes more and more valuable, as you can do much more in terms of assays at lower cost, you've run out of sample. The other thing that we're struggling with is the characterization of the health outcomes, particularly using data from health records. Because it's phenotyping of both the participants and their disease that's important. And in retrospective studies, you start with the disease. So you have very well characterized disease outcomes. Whereas in prospective studies, you start with a participant, and you can characterize a participant, but then you're linking into health record systems with all of their deficiencies. Often not as bad as you think, but you really need to kind of understand when you can trust the data in a health record system for particular outcomes and when you can't. And again, if you're thinking about building a resource, you're not just focused on, well, I'm a cardiovascular epidemiologist, therefore I'm going to make sure that the heart attacks are really heart attacks. You're trying to build a resource where there are thousands of different health outcomes that different researchers are interested in. And how do you develop a scalable approach to phenotyping those health outcomes? And I mean, people like Josh Denny here and others have been thinking about this. But again, I think one needs to consider what's the underlying strategy, scientific strategy, from the perspective of building a resource. And it's around this kind of balance between the value of breadth, so having a pretty good idea of what the health outcome is, versus depth of being very, very specific in terms of the characterization of that health outcome. And if you think about what matters largely in terms of a prospective cohort, if you miss some cases, well, you know, your power goes down a bit, but you're probably not going to produce a bias or a material bias in terms of your association with disease outcomes. But if you have false positive diagnoses, then that can produce problems, as we know. So the focus needs to be not on trying to find everything by going into all the clinical records and doing natural language processing, but finding most of the cases and being pretty sure they are cases. There will be certain circumstances where if you can drill down and subcategorize the health outcomes, then you'll get more specific associations. If you were to take breast cancer and look at associations, then they will be a kind of average of the associations with, say, ER positive, estrogen receptor positive breast cancer, and those that are negative. And so being able to subdivide those would be valuable in terms of getting the associations, or hemorrhagic versus ischemic stroke. And the question is, when should you go deeper? When should you not? And how do you go deeper? Can you use other data you have beyond the health record data? Could you use the genetics, for example, to kind of subdivide the disease outcomes? And I think that's an area where it would be really good to get the informatics community engaged. And then again, a little bit like the baseline, where collect lots of sample not knowing what you'll do with it. Collect lots of data where you can about the health outcomes, not knowing what you'll do with it. Could you, for example, link into the imaging data so that if people wanted to go deeper and they developed automated approaches to going deeper into imaging data, that you could do so? Could you identify and maybe even collect the tumor samples, having identified that people have developed cancer, and store those so that when tests develop over time, you could then go to those tumor samples? Or indeed, if we end up with all of the cancers in the UK being sequenced, linking into the sequence data. So it is this kind of balance between breadth and depth on the phenotyping of the health outcomes that I think is critical. So some other kind of considerations that came to my mind before the meeting and during it is the issue of feedback and recall by genotype. On the face of it, recall by genotype kind of makes a lot of sense. However, going back to people and telling them things they don't know does also have implications for the participants. So it may be great for research, but I think one of the things that has made UK Biobank work has been to tell people, if you join this study, you will get nothing back personally. You will not get any feedback. The advantage of that is that we can be pretty sure we won't harm them. Whereas with feedback, we will. And I'm saying we will, not we may, because we know that we do, because we tested it in the imaging, and we found that when we did give feedback, systematic feedback of what their scans showed, 20% of participants got feedback of potentially serious incidental findings. And only 1 in 8 of those turned out to be potentially serious. We removed benign ovaries. We removed benign bits of lung. We got somebody to change his will and sell his Rolls Royce because of feedback that was actually not informative. So I think the engagement that people talk about is, what is the engagement? I think the engagement should be around altruism rather than personal gain, that people are building a resource to help the population, and that they shouldn't be expecting that necessarily it will benefit them, although it most probably will. Another comment I wanted to make, and I'm sure I'll get shot down for this one, but I'll make it anyway, is the reward system. When I look through some of the papers for this, it talks about people who build these resources as data handlers. When you spent 20 years creating a resource, you are a data creator. There has been an enormous academic investment in building these resources. And yet again, in the discussion yesterday, it was all stick, no carrot. I mean, it was either take away money if people don't share data, or give them less money if they don't share data, which seemed to me to be the same thing. And so, I really do think that there needs to be a proper consideration of what are the incentives to build resources. What are the incentives, as we discussed yesterday, in low and middle income countries to build those resources and to protect the researchers and build the capacity locally to do research? How do we get PhD students to work on these cohorts, to create them, to maintain them, to enhance them, rather than just be the users of the data? And I think also we need to think about the kind of political issues around data sharing in local countries. So I think we need to think about the approach for data creation. And then a point about legislation. There is quite a lot of over-interpretation of the data protection laws, the European law. Actually, if you have pseudonymized data, then it is not covered. If you removed and you made it not readily possible to identify individuals, then there isn't an issue. But there is, like a lot of legislation, misinterpretation of the laws, and then that misinterpretation puts obstacles in the way of doing what one can do. So in terms of kind of summary of future strategies, I think, we need to establish several large prospective studies in different settings, but I think we need to do it in a strategic way, thinking about a resource for the world for this kind of research. That when we do that, the more we can get at baseline, because you only have one shot at it really, in terms of characterization. And how do we enhance that? Through data linkage about the participants, through remote monitoring, as well as with various devices, and collect as much and as different type of sample. Think about ways in which we can follow up through centralized health record systems, encourage where we do want to have these cohorts, the healthcare systems to become part of the solution to this and develop ways of turning those data into health outcomes. And finally, and something that we're really struggling with, once you've created this enormously complex data set, how do you actually make it accessible, not in terms of people being able to get at it, but actually people being able to understand it, understand the complexity of it, who may be expert in one area, but not expert in another area. How do you actually help them to visualize the data and to use it readily? Not just in the places with lots and lots of smart informatics people, but in the places where you've got lots and lots of smart people who could really turn these data into information. Thank you very much.
Yeah. So I was really taken by your description of the harms that come from feedback. Have you written this up?
Yeah.
Where is it to be found?
So we published the, this was the, so when we went and proposed imaging in 100,000 people. I went to Mark Warpert, and he said, well, what happens if you see a brain tumor? And I said, well, we're not going to look. And he said, oh, you can't go with that. No. So we did a comparison, a blinded comparison. The first 1,000 people who went into the pilot, we did what we had said we'd do, is that we would, the technician, if they really couldn't avoid noticing something, that would be checked, and there would be feedback. And there was feedback in 2% there. And then we said, and we'll do what is normal, which is all scans will be read, and we'll get feedback, and that was 20%. And only 1 in 8 of those 20% and 1 in 3 of the 2% were found to be potentially serious, and in most cases, actually even then, you were really pushing it.
Yeah, but my question is not the facts. My question is, where did you publish it? Because I think it's a really...
We published it, we tried to publish in a number of places, and we ended up publishing it through the Wellcome Trust online publishing.
Okay, so there is a reference, because I think other projects should be able to consider that input, and I have not actually heard it before. So it's on the line at the Wellcome.
Yeah, and when UK Biobank was originally set up, the original plan was there was going to be feedback. And then in the 2 or 3 years, the Wellcome Trust itself went through a consultation on this and considered what the implications, the pros and cons were, and they got to the conclusion that it would make sense not to have feedback.
And that strain often, especially in American projects, that it's patients' right to know everything, et cetera, and they can determine if they're going to be harmed. So it's just really interesting to have results where you can point to people selling their Mercedes or whatever it was.
Yeah.
Rolls Royce.
Well,
Sorry,
I did exaggerate. I exaggerated. It was a Bentley, actually.
Selling a Bentley.